Welcome to Study Loop.
All right, so it tells us that a solution is made by mixing 15.0 grams of SrOH2 with 55.0 milliliters of a 0.200 molar HNO3 solution. The first part tells us to write a balanced equation for the reaction that occurs between the solutes. So that's the reaction that occurs between SrOH2, which is going to be aqueous because it's in a solution, plus HNO3, which is also going to be aqueous because it's in a solution. Now, the type of reaction this is a double replacement. So for double replacement reactions, we want to break up these compounds and look at what the ions are so we can see how those ions are going to switch. So Sr, we know, forms a 2 plus charge because it's in group 2. We know that hydroxide is a polyatomic ion that we have to memorize, OH minus. In nitric acid, we have H plus, which is in group 1. We know that's a positive 1 charge. And then nitrate we know is NO3 minus. So that means that strontium is going to now react and form a compound with nitrate. Hydroxide is going to form a compound with hydrogen. So when hydroxide and hydrogen react, that is the acid-base reaction that's occurring, we get H2O liquid. And then the second compound we get is strontium nitrate. Since Sr is a 2 plus and nitrate's a 1 minus, that means we're going to need 2 nitrates. So we get SrNO3 2. This is an aqueous compound because it's dissolved in solution. So now we want to balance this reaction now that we have our framework. The easiest thing to do when you're balancing acid-base reactions is to look at how many hydroxides and how many hydrogen ions you have, because those are going to have to be equal to each other to make an equivalent amount of waters. So we have 2 hydroxide ions and only 1 hydrogen ion, which means I'm going to need to put a 2 here so that I can form 2 waters. So what I want to do now is just check and make sure that everything is equal. So I have 1 strontium on the left, 1 strontium on the right. 2 hydroxides and 2 hydrogen ions make my 2 waters. And then I have 2 nitrate ions on the left side and on the right side. So this is a balanced chemical reaction. The next thing that we're asked to do in part B, let's just say this is part A. In part B, they ask us to figure out how much of each ion is going to be remaining in solution. We want the concentration of each ion. So the first thing we need to do is figure out how much we have of each starting material. So let's start with strontium hydroxide. We know that we have 15 grams of SrOH2. So to go and figure out how many moles we have, we need to use the molar mass. So we look at our periodic table, we see that strontium is 87.62 grams, oxygen is 15.99 grams, hydrogen is 1.008 grams, and we add all of those components together. When you do that, you're going to get 121.634 grams per mole. Okay, so that, when we do the calculation, is going to give us 0.123 moles of SrOH2. So we have to do the same thing for our other reactant. So starting with 55.0 milliliters of nitric acid, We know that this is a 0.200 molar solution. Don't forget that molarity breaks up into units of moles per liter. That's how we're going to set up this conversion factor. So I'm going to try and cancel liters down here. But to do that, I need my milliliters to be in liters. So to go from milliliters to liters, I write 1,000 milliliters on the bottom and 1 liter on top. Okay. So that's going to let me cancel milliliters and milliliters. Forgot to cancel grams and grams up here. The next thing we want to do is set up our molarity, right? So we know that this is 0.2 moles per liter. So I want to cancel liters. So 1 liter on bottom to every 0.200 moles. Okay, that's going to cancel liters with liters. And when I do this calculation, I'm going to get 0.0110 moles of HNO3. So now I know how many moles I have of each one, and I know that I need to figure out which one's going to get used up first. Because I have two reactants, I'm going to have a limiting reactant. I need to figure out which one's limiting. Well, if I look back at my reaction, I know that I need 2 moles of HNO3 to every 1 mole of SrOH2. Well, I need twice the amount of nitric acid that I do of strontium hydroxide, but I have less of it, which means that this must be what's called our limiting reactant. So this is our limiting reactant, and this is our excess. So I need to figure out how much of my limiting reactant is going to consume of my excess reactant. So I do a conversion. So 0.0110 moles of HNO3, and we want to convert that into strontium hydroxide. That's going to tell us how much strontium hydroxide we use in the reaction. Okay, if we look back to the first page, we know that this is a 2-to-1 ratio. So since I'm trying to cancel nitric acid, that's going to go in the bottom. So 2 moles of HNO3. So every 1 mole of SrOH2. Okay. So what this means is I'm going to have 0.00550 moles of SrOH2 consumed. Right? Remember, this is the reactant that's in excess, so I have to figure out how much of it I consumed and how much is left over. So all of my nitric acid is going to go away. Right? I'm going to use up all of that reactant, and I'm going to use up only 0.00550 moles of strontium hydroxide. So I'm going to take 0.123 moles of SrOH2. This is what I have in excess, minus how much I consumed, which was 0.00550 moles of SrOH2. And that's going to be equal to what I have left, which will give us 0.118 moles of SrOH2 remaining. Okay, so now that I know how much I have remaining, I can calculate how much of each ion I have present. Okay, so I have 0.118 grams of SrOH2 that is remaining. I want to calculate how much of each ion that's going to give me. Specifically, I want to calculate how much of the hydroxide ion is left. Okay, so if we look at this, there are 2 hydroxides for every one of this entire thing. That unit should not be grams, that should be moles. So there are 2 moles of hydroxide for every 1 mole of SrOH2. So that's going to cancel SrOH2, or moles of SrOH2, and that's going to tell me that I have 0.236 moles of hydroxide left. Right? Of my limiting reactant, I don't have any hydrogen ions left. Okay? However, what we have to look at is what is participating in the reaction and what's not participating in the reaction. So I have hydroxide and hydrogen that are reacting. In every acid-base reaction, the general breakdown of the reaction is that you have H plus and OH minus reacting to form water, right? That's the compound. What's not reacting, what are called my spectators, are strontium and nitrate. They're not really doing anything. They're not participating in the reaction so much as they're spectating the reaction that's happening between hydrogen and hydroxide. So I know that the original amount that I had of both of those ions is how much I'm going to have remaining because they didn't do anything. They just spectated. So I had 0.123 moles of strontium hydroxide. Strontium is a 1-to-1 reactant here. There's a 1-to-1 ion in this compound. The same thing is true of nitrate. It's a 1-to-1 ion in this compound. So we know that we're going to have the same amount because it didn't participate, it didn't leave. So what that means is this is the amount of hydroxide that's remaining. And what I have left of the other 2, I have 0.123 moles of Sr2 plus, and I have 0.0110 moles of nitrate. And we just found out that we have 0.236 moles of hydroxide left over. So we're asked to find the concentration of these ions, not the number of moles. So we know that concentration is molarity, right? Which is equal to the number of moles per liter. So what I'm going to do is I'm going to take each of these and divide by the volume of this solution, which if we take a look back at the beginning is 55 milliliters. However, this has to be in liters because it's moles per liter. So we move the decimal point over 3 times, and we get 0.0550 liters. So we're going to divide each of these number of moles by the volume. Okay. So that is going to give us our concentrations. So the concentration of strontium is going to be 2.24 molar in Sr2 plus. The concentration of nitrate is going to be 0.200 molar, which if we take a look back at the beginning, this is the same concentration of nitrate that we started out with. And why does that make sense? Because I'm not using any of the nitrate. It's a spectator ion, so I should have the same concentration that I started with. And then of the last one, hydroxide, I'm going to get 4.29 molar hydroxide. Okay, So this is the final answer to part B. These are the concentrations of ions remaining. The last thing that we're asked is to tell whether the solution is acidic or basic. Well, remember, we said that we have 0 moles of H plus left, right? There's no more hydrogen ions. Well, we know that acidic solutions have hydrogen ions present. They have some concentration. We know that basic solutions have a concentration of hydroxides present. Since what we have is hydroxide present, that would make our solution basic. And we've already answered part C. Hopefully you found this helpful, and we'll see you next time.